Yeah, I have no idea because it's saying that I need to reconnect, but I can't reconnect without that number. So,
Have an email that tells you what your number was?
no.
And if you bring me the remotes, I'll show you how to make sure it's on if it's not on.
Oh, wait.
Okay, so this first one,
Mm-hmm.
it's asking for the T score,
Yes.
right?
Mm-hmm.
So you have 2.2 minus what divided by 3.3 divided by the square root of 9?
Okay, hang on.
Where's your mu? Where's the mu?
Well,
Oh, it's 0. Never mind. Never mind. Oh my gosh, never mind. That's why I told you this. I may have a hard time recalling this.
okay. Let me. All right.
So I have the t-score to equal 2. Is that right?
Hold on, I'm still working on it. Oops, what did I do? I just lost it. Oh no. What have I done? Oh, let me go put my dog collar on.
Did Susan, did you get the answer to that one?
No, I don't understand it.
Okay, so this is how I understand it. I mean, obviously, we're just doing this by hand. So your T statistic is going to equal your D bar, which is 2.2 minus the mu, which is going to be 0, because it always is. So it's just 2.2 divided by the standard deviation, which is 3.3, divided by the square root of 9. Is that right?
Okay, and I'm trying to find that formula. Sorry, hold on. Because I don't remember doing that. So hold on one second. Okay, yes. Okay, there it is. All right, hold on. Let me plug in the numbers here. Okay, so
T should equal 2.
Sorry, I'm slow on this. Forgive me for 1 second.
Wow, I don't understand how they're asking these questions.
I know.
The probability of being greater than 2.
This, to me, this doesn't even feel like anything that we've really done.
I mean, it kind of makes sense because it's okay. So.
Okay, Lori, walk me through that again because I'm not understanding.
Okay. So your t-score formula is
the x bar minus mu, right?
Right. But now it's d bar minus mu, and remember, mu in this situation is 0.
Okay, so, explain to me why that's 0 again.
Because with the mu difference and your null hypothesis is always equal to 0.
Okay, that's right. That's right. Okay.
Does that make sense?
Yes, that does.
So then you take your 2.2 divided by your standard deviation 3.3, which is divided by the square root of your sample size, which is 9.
Which is 9. Okay.
So it's that regular t-score formula, I believe.
Yeah, I think so. Okay, so then square root of 9 is 3, and 3.3 divided by 3 is 1. Okay, I got 1.1, but I was missing that step of the 2.2 divided by the 1.1. So it's 2. Okay,
Well,
that makes sense.
Where are you getting 1.1?
When you divide 3.3 by 3.
Oh, yeah. Okay. I just do it all on my calculator. Okay, so then the next one says the probability of being greater than 2.0 is 0.0403. Use the alternative hypothesis to determine the p-value for this test.
Whoa.
So
Okay.
to do that, do you just put 0.0403 in the place of 1.06?
What's 1.06?
What's 1.06?
So when I took my notes, I wrote down p-value equals 1.06 times 10 to the negative 11th is less than 0.05 equals theta. Equals alpha.
I don't remember that one.
It depends on what your alpha is, and they didn't give us an alpha.
So is
I think you just assume it's 0.05.
Because it says it's the probability of being greater, would we put that into the student T's probabilities?
So basically, how do we find the p-value for this?
They're giving you the p-value. It's 0.0403.
So how do we use
the probability, which is the p-value of being greater than 2, is 0.0403. Use the alternative hypothesis to determine the p-value for this test. Well, the alternative hypothesis says that mu difference is not equal to 0.
Right.
Oh, so we double that and get the p-value. We double 0.0403 because if it's greater than, that's a one-tailed test.
Oh
Maybe.
My word.
So we square it?
So we just do...
No, just double it.
Just multiply it by 2. 0.04...
Yeah, so 0.0...
times 2.
0.0806.
Yeah, and if we round it to 3 decimals, it's 0.081. I don't know. I don't know.
I have no idea.
I've never seen that question before.
Okay, hang on. So it's saying that the alternative hypothesis is saying that it's not equal to 0.
Correct.
Okay, then that means that you're gonna... Well, it means that the alternative hypothesis is correct.
Well, what it's saying is that we know...
Okay, the probability of being greater than 2 is 0.0403.
And 2 is the test statistic.
Right. So use the alternative hypothesis to determine the p-value for this test.
So the alternative hypothesis says not equal to, which makes it a two-tailed test.
Yes.
So if you have 2 and the probability is 0.0403,
then we just double it. Yeah, I think you're right. Yeah.
So it would be 0.01. 0.81.
So yes. 0.081.
Yes. Okay. I don't know. I've never seen this question before.
Me either.
I don't know. Okay, let's move. Susan, are you? Did we lose Susan?
We lost Susan.
Okay. All right, number 5.
Okay, let me get her again real quick.
Use the data file, chapter 12, data A, to answer questions 5 through 10. Make a column of differences. Use the chapter 12 data A.
Okay, hang on. So...
A. What's data A? Okay.
Got it.
You got
Where
it?
is
Where
Chapter
is it?
12 data A is under the data files,
It is?
and I can't open it because I can't get into SRSS. So I'm sorry, you guys. As soon as I get this figured out, I promise this is gonna go so much easier. I don't know why it unconnected me. Okay, so you go to the data, you open up to the reading, and then you go to on the right hand side under the main page and schedule. There's the data files. Go to that.
Okay, so it's actually a title of data title.
Yeah. It's
Data title?
yeah.
Okay, where do you find it? I'm trying to find it again. Say that again, Abigail. Oh, data files. Got it.
Data files need to go there.
Where? I don't have it. Is it under just the data?
It's under the data files. The link on the reading, it's at the very top
on the left-hand side.
on the left-hand side.
Okay, I've got the data files pulled up, but I don't have.
So, scroll down towards the SRS ones.
Yeah, it says Chapter 12, Data A.
Oh, okay. There it is. Okay. Chapter 12, Data A. Okay. Let's see if I got that pulled out.
Well, this is the worst. I can't do anything because I don't have the information. But if you guys want to give me the information, then I can actually do it with you.
Oh, it's probably too much data.
Sorry, mine's still pulling up really slow.
Okay. So we're doing another two-tailed test, and with the level of significance at 90%.
Okay, hold on. Sorry, I'm still
You're
pulling
okay.
up.
You're okay.
Okay, are your numbers number 1, group 1, 202, 362, 114?
Yep.
Okay, all right. Making sure. And you have 20 numbers?
Yep.
2 columns, right?
Yep.
Okay. Okay,
Now we're going to subtract them. And this is where I get super confused, is how you're supposed to subtract them.
Okay, I have to go through that. Hold on.
But I'm going to do group 2 minus group 1.
Yeah, that's what I usually do too. And when it's group 2 and group 1, I think usually it doesn't matter too much.
It doesn't, but it confuses me. You know what I mean?
Yeah, no, I know what you mean. I'm just saying I think usually unless it specifies
right
what you're doing, I don't think it matters too much. Okay, I've got my differences. Now what are we doing? Let's see. Okay.
What is D? So now we're going to analyze them, right?
Yeah.
And we're going to do the one sample t-test, correct?
That's what I always do. On the difference, and did you say we're doing it at 90%?
Yes. Because it said, right, 0.10. Yep.
And our test value is 0 because our... Okay.
Right.
Okay.
So the D bar is the mean, correct? So I have a minus 31.
Yeah.
0.025.
Yep, that's what I've got too.
Standard deviation is 341.157.
Oh. All right. Okay. Sorry, getting a little bit behind here. Negative 31.025 for the D bar, right?
Correct.
Standard deviation is 341.157.
Correct.
Okay, what was D bar again?
Minus 31.025.
Okay.
Number 6 is 341.157.
Okay.
Number 7 is negative 0.407.
Yep.
Right, Stephanie?
That's what I've got, yes.
And then I have the p-value because it is x is not equal to 0. It's a two-tailed test.
Right.
So it's 0.689.
Yes, that's what I've got.
So does that make number 4 sound right then?
Yes, it does make number 4 sound right.
Okay. So then we have to do 0.40, let's see, the p-value 0.689.
That's larger than the, what was our?
0.10.
0.10, okay. So 0.6.
Reject the null. So the p is greater than, so we fail to reject the null.
Wait, if it's 0.10, wouldn't that be 10?
Right, but this is
So-
0.68. So this is, so if you do it in percents, it's 10% is less than 68%.
Oh, right.
So 0.689 is greater than 0.10.
Okay, so we fail to reject the null.
Yeah, because if p is low, reject the null. And so now we're failing to reject the null.
Right. Okay.
Oh gosh, I hope this is right, you guys.
Okay, I'm sorry. I'm really bad on these, on the decimal thing. So that would be 68%. So the 0.10,
Is 10%.
it would only be 10%. It wouldn't be 100%.
Correct.
Okay.
Because you have to think about it, you're looking at the 90% level of significance, so that only leaves you that 10%.
Okay. Okay.
And then if you turn
I'm
it
so
into
bad at that.
percents, then it's easier with the greater and less than to determine what's bigger and what's not.
Right. Okay. That's what I need to do. Is I just need to turn it into a percent.
Yeah.
Okay.
Okay, so then suppose the alternative hypothesis is greater than 0. What is the correct decision based on this evidence? If the hypothesis is greater than 0, well then if it is greater than 0, and we still failed to reject because the null hypothesis is equal to 0, right? Oh,
Okay, hold on.
Oh my
Let me
gosh.
think this through here. Okay. Suppose your alternative hypothesis is greater than 0. What is the correct decision based on this? Our p-value was still going to stay the same, right?
Right.
And the whatever it's called is still the same. The it's 10%.
Yeah, so the alternative hypothesis is true. So we would reject the null. No.
Yeah. Okay, suppose your alternative hypothesis, okay, then it would be true. Yeah. I think it's reject the null hypothesis.
For 9 or 10?
For
For
10.
Okay, that's what I thought. But I was getting
Okay, hold on. Let me think this through really quick.
yeah, I got it. Something's not right there that I don't understand.
Suppose your alternative hypothesis is HA. Okay, I'm going to write down the regular hypothesis first, which
I'm
was
already doing that.
okay. D is equal to Z.
what?
Alternative hypothesis. Okay, so now what we would do is we would plug in those numbers for the alternative hypothesis, right?
Yeah, the thing is you still fail to reject the null in my brain.
Okay, hold on.
Because no matter what, Oh, if P is low, reject the null.
Yeah, you're right. If P is null, wait. Okay,
Yeah.
if P is null, reject the null, but it doesn't, the numbers don't change, so the P is still greater than our...
Yeah, so wouldn't you still fail to reject the null hypothesis?
Yeah, I think so.
Did we answer number 9 correctly? If P is low, reject the null. So the P is not low, it's high.
Yeah, it's high.
So we fail to reject.
Yep.
And then if we plug those answers in again, it's still just because the alternative hypothesis failed. I mean, is both of the alternative hypothesis is true, because the null because the mu d not equal to 0 is true, and the mu d greater than 0 is true.
Oh, yeah, you're right.
So both of them are true.
Right. So we would still, yeah, so we would fail to reject the null hypothesis then on both of them.
Oh, something isn't making sense to me. If P is low, reject the null. P is high, so we have to fail to reject the null. I don't know how else to think about that.
I don't know either.
All right, let's move on.
I'm sorry, I have no idea. I have no idea. Which is greater, N or DF? N is greater, right?
Wait. No. Now you've got to bring up new data. You're on chapter 12, data B.
Okay, I know, but I mean, question 11, which is greater, N or DF? N is always greater than DF.
Yeah, but you don't know what N is yet. You have to pull up the new data. This is chapter 12, data B. You're still working on chapter 12, data A.
Okay.
Oh, but yeah, you're right, because the DF is N minus 1.
Right.
Right?
Right. Okay.
Yeah,
data.
Sorry. And I'm worried about...
You're fine, Lori. Don't worry. I knew where you were going.
Because I'm still at the part that says, use the data file.
Yes. Okay, now I've got to pull this up. Where did it go? Let's see. I don't know what it's doing. Hold on. I have to pull a whole new thing up.
Boy, mine is going so slow today.
Yeah, I'm struggling here, so hold on, bear with me. I've got to pull this all up again. All right, data B is what we want now.
Yeah. Sorry, I just didn't go on to 11 until we had this all pulled in, so.
Yeah, no, you're fine. Sorry, it's still pulling up. Hold on. Okay, I finally got it pulled up now. So group 1 starts out with 69, 34, 39. Is that right, Lori?
Yep.
Okay, here we go. All right.
Okay, and we're working on a 0.01, so we're at 99% now.
Okay. And are we doing the group 2 minus the group 1 again?
Yep, yep, I did that.
Okay. So now,
Oh my gosh. Okay. Okay. Okay, go back.
go back to what?
If the p-value to question 8,
Okay.
if that p-value is 0.689 and the alternative hypothesis is equal to 0, that's a two-tailed test. If it turns greater than 0, we have to take that p-value and cut it in half.
Oh.
Sorry, I'm backing up. Something just came
Yeah.
to my brain.
You are right. Good thinking, Lori.
Okay, so then what that does is that makes your p-value for the alternative hypothesis in question 10, then the p-value becomes 0.3445,
Yes, that's what I got.
which is
Which
still greater
higher.
than 0.1.
Yeah.
Okay.
So we still fail to reject then.
Yeah. Yeah.
Okay.
But what that new hypothesis did was make it a one-tailed test.
Yes. Yes. Okay.
So, okay, at least that makes sense to me. Sorry.
Yeah. No,
right.
great. I'm glad
Moving
you.
on. My gosh.
I know, this is crazy.
Because the first question in this next one is, what is the p-value?
Mm-hmm.
And so we have so it's 0.001, right?
Trying to keep my charts all here. Yes, I have 0.001.
And it's a two-tailed test because
And it's a two-tailed test, yes.
Okay.
Because it's a equal or not equal to.
Right. And so we reject the null hypothesis because 0.001 is less than 0.01.
Yes. Yes. Reject the
null.
null.
Reject the null.
Yeah, that's null.
Okay.
Reject.
So 0.001 is less than 0.01.
Right.
Okay. So now we're going to do this again. You decide to try another alternative hypothesis. This time you use greater than 0, and you keep the same level of significance. Did the p-value increase or decrease?
Decrease.
And it decreases because we divide it in 2, correct?
Yes. And then it's 0.0005.
Yes. Okay. You decide to try another alternative hypothesis. Oh, wait, I did that. So decrease. What decision did you make then? Well, we continue to reject the null, correct?
Yes, because it's low, so we reject the null.
Oh, Stephanie, I hope if this is wrong, then I don't get this at all.
I know, me either.
And I will cry.
I know.
Okay, as we have seen, the p-value depends on the alternative hypothesis. Setting aside the data in this problem, do you think a general rule can be which alternative hypothesis will give the smallest p-value? You don't have enough information.
Yeah.
You have to know the p-value.
Yeah.
Well, which alternative hypothesis will give the smallest p-value? The smallest p-value. Well, well, mu difference not equal to 0 is going to be your highest p-value, correct?
Right. Right. Yes.
And the other two are going to be cut in half.
Yes. But
you can't. So there's not enough information.
Yeah, I think that's.
I mean, because we know that equal to 0 is the biggest, and the other two are equally the same because it's just cut in half.
Right, and increase or greater than or less than, it doesn't matter. It all depends on the number.
Right.
Right now, I think that's the right.
And we can't choose more than one, right? Nope.
I don't think so.
Okay.
No.
Okay, so now we're gonna. Okay, now we're doing the confidence interval. So now we go into analyze, descriptive stats, explore.
Yeah. And we're still doing it on the differences, right?
Right.
And we're doing what percentage? 95%. Okay.
So that's already in there, right? Yeah.
Yeah. Oh, wait. There it comes. Okay, I'm like, wait, it's still on 99%. Okay, so making sure I've got all the, I've got negative 18.6065 and negative 5.3025.
Yep, that's what I have. So negative 18, and we got to do it to, well, I assume 3, so 0.607, negative 18.607.
Wait. Read the question. Determine the 95% confidence interval for the mean difference between the two groups. What is the lower bound? So we have to do the lower bound first.
Right, which is negative 18.607, right?
Oh, wait a minute. No, hold on. Oh, yes, I'm reading it wrong. Yes, good thing you caught that. Yes. Okay, so negative 18.607. Yes.
And then the upper bound is negative 5.303, rounded to 3 spots.
Negative 5. Okay, hold on. Negative 5.303. Yes, negative 5.303.
Determine the 95% confidence interval for the mean difference between the two groups. So we're looking at the difference.
Yeah, differences, 95% confidence interval.
What is the lower bound and what is the upper bound? That's the only way I know how to do that.
Me too.
Okay, so let's go over our answers again.
Yep. Okay.
And I'll tell you what, I don't know of any other way to think about this. So if this is wrong, we need help.
Yeah, agreed.
If we do it wrong, we'll talk about it to the tutor tomorrow.
Number 3, hold on just a second. Okay, number 3 is 2.
Mm-hmm.
Number 4 is 0.081.
Yep.
Number 5 is negative 31.025.
Yes.
Negative 6 is 341.157.
Yes.
7 is negative 0.407.
Yes.
8 is 0.689.
Yes.
9 is the second one.
Mm-hmm.
10 is the second one.
Mm-hmm.
11 is n,
mm-hmm.
which is greater. 12 is 0.001.
Yes.
13 is reject the null, number 1. 14 is decrease.
Mm-hmm.
15 is reject the null.
Mm-hmm.
16 is not enough information.
Mm-hmm.
17 is negative 18.607.
Mm-hmm.
And 18 is negative 5.303.
Yep. Okay. I hope this is right.
So negative 18.607, negative 5.303,
Yeah.
and then for 12, it's 0.001. Correct?
Well, it's just 0.001.
Okay.
Stephanie, anything you think we should look at again?
No, but I mean, I'm not 100% sure on all of these, obviously.
You know what? I'm not 100% sure on any of these.
Yeah.
This
This was a hard quiz.
Yeah. I felt really bad. I wish I could have helped you guys more. I'm so sorry. I'm gonna get this fixed, I promise.
we
As
got
of the next-
100%. We got 100%.
Oh, good. All
I
right,
promise
good.
you guys, as of the next meeting, I will have that up and running if it kills me.
Okay.
Well, that's only going to help. You got to get that done so it helps you, Abigail. Otherwise, the longer you wait, you're going to get further and further.
Yeah.
I don't know, unless you're just smart and can pick it up fast. But that's
Right.
not me.
I'm not that smart. So yeah, I will
Okay.
be meeting with the tutor tomorrow and I'll get it fixed then.
Before
Okay.
we go, I want to hurry and talk to you guys about this design or this study that we have to do.
Okay.
But it looks like, okay, I didn't read through all of it. I just thought we had to come up with our own things, so I wanted you guys to be thinking about it. But it looks like they give us a list of possible topics that we can choose from to study, so that's good.
Okay, I'm looking at it here. How did you know to come here?
You know what? I was playing around with this the other day because I was so frustrated and I needed a break from just doing statistics. So I wanted to count down how many more days we had.
Don't worry, I do it all the time.
So I happened to just click on this, and I'm like, oh, we have a project that we have to do.
Yeah, and I've
there
been
is an
kind
exam
of,
next week.
yeah, I'm sure we'll come up with something. Stephanie, I'm sorry I didn't call you on the weekend. I can still go over some of that. I just had, my daughters came in town.
You're just fine, Lori. I'm not worried. We don't have to register till November. I just thought I would ask you if you had any suggestions or do not take classes together type of thing.
Right.
You know?
So when we talk, because maybe we can talk Thursday after this class. If you
Okay.
bring a list of the classes you still have to take, that would help me to know
Yeah.
what
I
classes
can even,
are hard.
I'll
you know what
email
I mean?
you, I'll email you a list of what classes I need to take, and then you can, if you don't get it done before, then don't worry about it,
Perfect.
okay?
Perfect. Let's do that.
Okay, sounds good. All right,
Thank
guys.
you,
Well,
everybody.
yep, we'll see you Thursday.
All right.
Okay. Bye-bye.
All right, bye.
Bye.